Hi everyone, welcome to this first lecture of ECON 220W Summer Term 2021. In this lecture, I'm going to make a review of competitive markets. Those are concepts that you've seen in Econ 103 or Econ 201. I will remind some definitions again about economics, about allocations, and I will go over the definition of a market equilibrium. So, let's start with the definition of economics. Economics, or economic science, is the science that studies the allocation of finite resources. Here I emphasized two terms, allocation and finite. The world is full of finite resources that we deplete on a daily basis. Think about oil, think about water, and so on. Some of these resources can renew themselves. Others don't renew as fast as we would like them to, or simply don't renew. Economics is going to study the allocation of these resources. Since they are finite, we need to be efficient in their allocation. We want to avoid waste. So economics is broader than just a market, dollars, currencies, and finance. It's about allocating finite resources in the most efficient way possible. But that includes natural resources, that includes time, that includes how much time you should spend working versus how much time you should spend having fun. That is also about how you allocate wealth. The government has a certain amount of tax revenue, how they allocate this revenue to the rest of the population, and so on and so forth. Along with this definition then, will come the definition of what we call a Pareto optimal allocation. So, this is going to characterize a certain type of allocations that are, in general, desirable. An allocation is Pareto optimal or Pareto efficient, and more generally, when we say efficient, we mean Pareto efficient. If there is no other allocation, goods, money, time, any other resource, that would make somebody better off without making somebody else worse off. So Vilfredo Pareto is an economist from the end of the 19th century. I believe he's Italian, who came up with this idea of an allocation being efficient. Think about an allocation as being a list of who gets what. If you think about goods, you could think about who gets the muffins at Tim Hortons. If Tim Hortons doesn't sell them, Tim Hortons is keeping the muffins, or they could go to some customers. Same with money, same with time. You take some time to do this and take some time to do another activity. An allocation is a list of the current way goods, money, time, or other resources, space, are being allocated. For example, the list could be, I have $5 in my pocket, you guys have $10 in your pocket. That's an allocation. Is this allocation Pareto efficient? It is if there is no other allocation, so there's no alternative that makes somebody better off without making anybody else worse off. In the case, for instance, where I have $5 in my pocket and you guys have $10 in your pocket, any other allocation would mean that some money would be moved. Maybe some of your $10 would go to my pocket, or maybe some of my $5 would go to your pocket. But in this case, in any case, somebody is going to lose some money. So in this case, we can say that the actual allocation, where I have my $5, you have your 10, is Pareto efficient. Because if you want to change things in any way, somebody is going to be worse off. Imagine, for instance, that I walk in the street and in Vancouver, and I find a $5 bill on the floor. Given that it's Vancouver, with all this rain, probably nobody else will get the dollar bill and it's going to get washed off by the rain, maybe go to the sewers or something. So at this stage, there are a couple of allocations. The first one is, I take the money, keep it for myself. The other one is, I leave the money where it is. Which allocation is Pareto efficient? Well, if I leave the money where it is on the floor and nobody can get it, assuming nobody can get it, then another allocation would be the one where I take the money. It would make me better off because I would now have $5 in my pocket, which I did not have before, and nobody else around me will be affected. So, the allocation where the money goes to no one and is on the floor is not Pareto efficient because we can find one allocation which is better. The allocation where I take the money. So you can see how the notion of Pareto optimal allocation is related to the notion of waste. If I leave the money on the floor and nobody's getting it, you can consider this a waste. Same as leaving $5 on the table and no one can get them. It's a waste in the sense that one person at least could be better off. One person could be happier with this money and nobody else would be affected. It is one type of efficient allocations among many other efficient allocations, but in economics in general, we focus on Pareto optimal allocation. It's very vague, very broad, but at least it gives us a criterion on how an allocation should be, which is desirable. Here's another example. Take two individuals on an island. One of them is a billionaire and owns all the resources on the island. The other individual has nothing. He lives there, just survives, but doesn't own anything. Is this allocation Pareto efficient? Well, it technically is. Because if you want to make the second person better off, this person has nothing, just surviving, then you need to take something from the billionaire, because the billionaire owns everything on the island. If you take something from the billionaire to give it to the other person, you're going to make the billionaire worse off, although you're going to make the other person better off. As soon as you make somebody worse off, it cannot be an improvement. So the actual allocation where one person owns everything and one person owns nothing is actually Pareto efficient. Note that, of course, probably if the billionaire gives a coconut away to the survivor, the billionaire won't be that much worse off. And the survivor, however, will be so much better off with the coconut because he can feed himself for a day or something. But since one of them is worse off, the allocation is technically Pareto efficient. This also shows you that an allocation can be efficient, Pareto efficient, but it's not necessarily fair. A world where one dictator has everything and everybody else has nothing is actually Pareto efficient because there is no waste. But you can see how it is not desirable from an ethical point of view. So we care about making allocations efficient to make sure there is no waste, but then we have to figure out, can we make it more fair? Can we make it nicer while being efficient? And governments in general can step in and choose which allocation is going to be more fair. In fact, if you think about redistribution, getting a tax credit or tax return every year for poor people is a way to keep the allocation Pareto efficient, but to make it more balanced, to make it more fair. The allocation where the government doesn't tax anybody is also Pareto efficient, but in this case, rich people would be very happy. By taxing rich people, and in general taxing them more, governments can use the tax revenue to redistribute the money to poorer people. The allocation is still Pareto efficient once you get there. Moving from one to the other, yes, is going to make rich people worse off. But once you are at the allocation where you gave some money to the poor people and you took some money from the rich people, that new allocation itself is Pareto efficient. Because if you want to rechange that allocation, you're going to make somebody worse off again. So in this case, we go from one Pareto efficient allocation to another. They're both Pareto efficient, but one of them is more fair, nicer. And in general, this is the role of the government to step up and say, okay, let's shuffle things a bit and let's reduce inequalities. Let's now go over a simple market. A market in general has two sides, the demand and the supply. I'm going to start with the demand. The individual demand curve represents the quantity a consumer is willing to purchase for a given unit price. So price is taken as a data. When you walk in Tim Hortons or Starbucks, the price of a coffee is what it is. You don't have any impact on it. There's no bargaining. The demand curve is going to tell, your demand curve is going to tell how many coffees or what the size of a coffee or how many muffins you are willing to purchase given the unit price of a coffee or a muffin. The aggregate demand curve is going to be the sum of all those individual demands. Your demand plus my demand plus somebody else's demand. And overall, when a coffee at Tim Hortons costs or tea costs $1.95, for this price in one day, that much tea is going to be sold. That represents the aggregate demand. In my case, for $1.95, I want to buy one tea. That's my individual demand. So it represents a quantity as a function of the price. Q as a function of P. The inverse demand shows the opposite relationship, the inverse relationship. Instead of having Q equals something that depends on P, now we have P equals something that depends on Q. It is just the reverse. Instead of isolating Q, I isolate P in my equation. It turns out that this is the kind of graph we will mostly look at. On the y-axis, there will be P. So P will have to be a function of Q. This is why we usually plot the inverse demand function. The inverse demand function depicts the price consumers are willing to pay not for Q units of the good in general, but for the Qth unit of the good. So if you look at a demand curve and you look at the demand when Q is equal to 10, that represents the price people are willing to pay for the Qth unit of the good, for the 10th unit. And the price they're willing to pay for the 10th unit is not the same price as the price they're willing to pay for the first unit. In my case, I am willing to pay $2 for a tea or $3 for a first tea, but I'm willing to pay $0 for the 10th tea because I don't need 10 teas in a day. I'm willing to pay some money for a second tea as well, maybe a third, but never beyond 3. But for the second or third tea, I might be willing to pay less money because what matters most is the first one. The first one is the one that gives me the most satisfaction. I don't need 2 or 3 teas during the day, but I definitely need or want one. The first sip feeling, right? With the demand curves comes the definition of consumer surplus. The consumer surplus is the difference between the price a consumer is willing to pay for the good and the price she actually pays. If I am willing to pay $3 for tea, but I actually pay $1.95, then the difference between the two is what we call the consumer surplus. Because not only I will get utility from drinking my tea, but I will also be happy because I have some change left in my pocket. In this case, my surplus is equal to $1.05. $3 minus $1.95. Consumers have the objective of maximizing their surplus. They want to consume goods that they like, but they want to pay as little as possible for them, right? And this is shown on the following graph. The following graph shows the inverse demand. Why inverse? Because here, dollars, here represents the price as a function of the quantity. In this example, I am looking at the allocation of Canucks tickets. So there is a Canucks game in Vancouver, I guess post or pre-COVID, and the aggregate inverse demand shows the price people are willing to pay for each unit of the ticket. People overall are willing to pay $100 for the first unit. This is actually this point here. At the point 0, this means this is the price they're willing to pay for the first unit. At point 1, this is the price they're willing to pay for the second unit, which is $80 for a second ticket. For a third ticket, they're still willing to pay $80. For the fourth ticket, they are willing to pay $50 now, and so on and so forth. Imagine the price of a ticket at the end of the day is P star. This is the price of any ticket. Then, at this price, consumers are willing to pay $100 for the first ticket, but they pay P star, which is here $45. So they're going to buy that ticket. They're willing to pay $80 for the second ticket. Since the ticket is worth $45, they are going to pay for it. And so on and so forth. Once they get to 5 tickets, here it shows that they're willing to pay $20 for a 6th ticket. But since the ticket is worth $45, they're going to stop at 5. And so 5 here will be the number of tickets purchased overall by the demand. 5 tickets will be sold on the market. The consumer surplus will then be the difference between the price consumers were willing to pay and what they actually pay. On the first ticket, they were willing to pay $100, but they pay $45. So the consumer surplus will be this vertical segment here, which is equal to $55. On the second ticket, they are willing to pay $80 and they pay $45. So now their consumer surplus is going to be here, and it's going to represent, it's going to be equal to $35, and so on and so forth. Once they get to the 5th ticket, they are willing to pay $50 for the 5th ticket. They pay $45, so they have a consumer surplus of $5. This is the extra utility on top of enjoying the Canucks game. What about the other side of the market? The supply. Well, if the demand represents the quantity people are willing to consume, to purchase, the supply curve represents the quantity producers are willing to sell at the price P. If the price on the market is out of their control, and it's, let's say, $10, they are willing to sell a given quantity. That's the supply. Then you can compute the aggregate supply curve by adding up the supply of all the firms in a market, in an industry. And then you can invert the relationship to get the inverse supply curve, to get price as a function of the quantity. Again, this is the price they're willing to sell the qth unit of the good for. Analogously, we get the definition of producer surplus. The producer surplus is the difference between the price producers are willing to sell the good at, the price they sell the good at, and the price they're willing to sell the good at. It works the other way around. It's going to be easier on the following graph. The supply curve here shows the price that producers are willing to sell the good at for the qth unit of the good. So if I go to 0 here, they're willing to sell the first unit of the good. It's an extra unit. They're willing to sell an extra unit of the good for $0. That means in general that it doesn't cost anything to produce the first unit. Second unit, same, 0. Once they get to the third unit, so Q is equal to 2 and they go to a third unit, they're willing to sell the unit for $30, probably because this unit becomes costly to produce, and so on and so forth. The supply curve in general is increasing, due in general to the increase in costs. The more you want to produce, the more it costs, and so the higher price you're willing to sell the good at. Or equivalently, if the price is very high, then producers are willing to sell a high quantity. Imagine the price on the market is P star. The producers have no impact on the price. The price of a ticket is what it is. It's been decided by another firm, and it is what it is. Then, producers will have a producer surplus on the first unit of the good equal to $45, what they sell the ticket at, minus 0, what they were willing to sell the ticket for. On the second unit, same thing. We get this distance. On the third unit, they are willing to sell the good at $30 and they sell it for $45. So they still make a surplus of $15, and so on and so forth. Note that since the supply function is a representation of the marginal cost curve, the producer surplus is a measure of profit. It is the difference between the revenue on each unit, $45 per unit, minus the cost of each unit. If you add all those things together, you get the red area, which is a measure of profit. The same way, the consumer surplus is a measure of utility after paying for the good. The utility net of paying for the good. Note here that the supply curve and the demand curves are step functions. They look like stairs because we cannot sell 1.5 tickets. It's either one ticket or two tickets. In general, when we consider divisible goods, we will be looking at straight lines or curves, but we won't look at step functions. For instance, if instead the market was the market for sugar, you don't count sugar per unit, you count it by weight. So there is a certain price that people are willing to pay for 500 grams, 512 grams, 512.2 grams, and so on. So if the good is divisible, we won't get this step function. Now that we have the supply and the demand, let's see what happens when they meet on the market. On the market, the situation where supply is equal to demand is called the competitive equilibrium. At this price P star, consumers are willing to pay $50 for the fifth unit and more for the previous units. Producers are willing to sell that unit for $40. So they want to sell that unit. Consumers want to buy it. Producers make a profit of $5 on that last ticket. Consumers make a consumer surplus of $5 on that last ticket. And on the sixth ticket, consumers are willing to pay $20, whereas producers are willing to sell the ticket for $70. So, consumers are not willing to pay a price that is high enough for the firms. So, the 6th, 7th, and 8th tickets won't be sold. Consumers will stop at 5, and producers as well. So what happens is, all the tickets the producer is willing to sell will be purchased by the consumers. So there is no waste in this sense. The producer won't produce 6, 7, and 8 tickets. At the market equilibrium, only 5 are needed. Of course, when I talk about this, here everything happens simultaneously. Everything happens at the same time. It's as if supply and demand could coordinate instantaneously. In real life, there are adjustments. In real life, the producers could start with, let's say, a ticket of $90, and they see that one person wants to buy for $90. But then they're like, okay, but I can maybe lower my price because I can still make money. I can lower my price and sell more tickets. And then somebody's going to be willing to pay $80 and so on and so forth. So there are some little adjustments in real life. But this is a model, and this is a representation of what's happening once there is a competitive equilibrium. Now, I talked about Pareto efficient allocations before. How is this related to a market? The first welfare theorem there are two welfare theorems, is a very important theorem that says that under certain conditions, every competitive equilibrium allocation is Pareto efficient or Pareto optimal. So, if this can happen, of course, there's a bunch of conditions which I'm going to talk about. If this can happen, then there is no other allocation that can make somebody better off without making somebody else worse off. If you think about 5 tickets, for instance, here. What if the 6th ticket was given to the consumer or sold to the consumer? Well, for the consumer to be better off, it would have to be sold at a price lower than $20. But if firms sell that extra ticket for $20 or less, they are going to be worse off because they are going to make a loss. They are willing to sell the ticket for $70. If they sell it for $20, that represents a loss. So any extra ticket you would like to give to a consumer will make producers worse off. On the other hand, if this 5th ticket is not being sold, imagine this 5th ticket stays in the hands of the producers. And the allocation is 4 tickets are being sold to consumers. Can we do better? In fact, this 5th ticket could be sold by producers for exactly $45 or anything between 50 and 40, because anything between 50 and 40 is something that consumers are willing to pay for. It's not higher than 50, so that's good. And anything above 40 is a price that producers are willing to sell the ticket for and make profit. So if only 4 tickets are being sold here, there is a miss because the 5th ticket could be sold as well. Producers would make a profit out of it, and consumers would get some surplus out of it. So it would not be efficient if only 4 tickets were sold. It is efficient that 5 tickets are being sold. Any more tickets represents a loss for producers or a price too high for consumers. Any less tickets represents a missed profit for firms and a missed consumer surplus for consumers. So it is Pareto efficient. Now, what are these conditions? First of all, we need perfect competition. Perfect competition gathers 5 different conditions. First of all, producers and consumers are so small that they don't matter on the market. They don't have an influence on the price. The price is as it is. Second, the product is homogeneous. The product being sold on the market is exactly the same. Of course, in real life, it's not the case. If you want to buy a ticket to a Canucks game, some tickets are going to be worth more because they are at different locations. So every ticket is not the same. Third condition, there is no imperfect or incomplete information. So information is perfect in the sense that it is free, it is accessible at any time at no cost. So if somebody wants to know the price of a ticket, they have the ability to know about it right away without any error, without mistake. 4, inputs are perfectly mobile. so labor and capital or any other input, can be used in any flexible way. That is a way to make sure that firms are not facing input constraints that might have to make them charge a price above the marginal cost. And the fifth condition is that there are no barriers to entry or exit to the market. If it's easy to enter a market, then firms will enter a market where there are profit prospects. As they enter the market, there's going to be more and more competition, which eventually is going to reduce profits, and profits will go to zero. But when we say that profits are equal to zero, be careful. It's a good thing for firms. Profits contain costs, all the costs. So if you make a profit of zero, it means that you are able to pay everybody in the firm, that you're able to pay all your suppliers, pay your debts to the bank, and even pay yourself as a CEO. Everything is included. So if at the end of the day you have zero left, it's fine. Everybody got paid. A positive profit in economic theory would mean extra money. If there are no barriers to entry or exit to the market, then any firm that sees, oh, I can make profit in this market, will get in. As firms get in, it will increase competition, reduce profits, and eventually we'll go back to price equals marginal cost and profits are equal to zero. Same thing, if you need no barriers to exit the market. If a firm doesn't make any money anymore, maybe now is making a loss, wants to exit the market, it should be able to do so. In real life, many markets are actually hard to enter. In particular because sometimes huge investments are required in equipment. Firms need to buy a lot of equipment if they want to produce. However, firms which are well established in that industry already acquired this equipment. So they can adopt predatory behavior. They can charge a lower price momentarily to make sure that nobody wants to enter the market. That is anti-competitive, and that will make sure that the incumbent, the well-established firm, will stay in this industry and will keep its market power. Another condition is that there are no externalities. I will get into this in 3 weeks. Externalities are the consequences of an agent's decisions which are not taken into account by the market. If, for instance, you decide to buy cigarettes and smoke them next to somebody, this person's utility will decrease because of secondhand smoking. But when you consume your cigarettes and when you buy them, you don't take into account the amount of harm you could cause to bystanders. There could be a better allocation. A better allocation would be the case where maybe you smoke next to this person, but you're paying this person to be allowed to smoke. You're paying this person a bit so that at the end of the day, surplus is maximized. We will go into externalities in detail. That also covers good externalities, good things. Too many of bad things are being consumed or produced, and too little of good things are being produced or consumed. And it's because of that we get a market failure, inefficiencies. And we'll see how to correct that when the time comes. And finally, no public goods. Public goods will also come in the same lecture as externalities. Public goods are very specific in the sense that they are non-rival and non-excludable. You cannot exclude somebody from the consumption of a public good, and an extra person consuming the good is not reducing the availability to others. For example, a lighthouse. Everybody can enjoy the light of a lighthouse in the same way. And you cannot exclude somebody from seeing the lighthouse. It's a public good, and if one person can enjoy it, so can 1 million people. And you can see how this could be a problem on the market with a private firm. You just need to make one unit and everybody can enjoy them. enjoy that unit. So I already went through perfect competition. Market participants take prices as given because they have no market power. In general, we also say that they are so little, so small, that they don't have any influence on the market. The market is way too big for each of them. Perfect information. They know what the goods are about. They know their prices with certainty, with no noise or no potential mistake. There are no barriers to entry or exit to the market. The good is homogeneous. It is the same exact same across producers. The reason behind this is if the goods are slightly different, then consumers might choose to pay maybe a higher price for a certain good because of different features. The idea of perfect competition is that the only way two goods are going to compete is in price. So the goods have to be the same so that the only thing that is going to distinguish them, that is going to make a consumer choose one over the other, will be the price. And production inputs are perfectly mobile. I talked about externalities in public goods as well. So a big chunk of this course will be about breaking those conditions one by one, not all of them, but some of them here and there, and see how it's going to influence the market outcome. See how inefficient things are going to get. Perfect competition provides a benchmark where total surplus, consumer surplus plus producer surplus is maximized. It is another feature that perfect competition, perfectly competitive markets have. Note that in real life, perfect competition barely exists. Maybe it exists in agriculture, but that would be maybe the only market. It is a benchmark in the sense that if you want to know what's going wrong with something, you need to know what it means to be right. How do you know when you're sick? Because you know how it is to feel okay. So we need a benchmark to see what is the best case scenario. Perfect competition. Now, in real life, this condition or that condition or that condition do not hold. What is going to happen and how can we solve the problem? So in this course, we will go over different market characteristics. Monopoly, for instance, is the case where there is only one firm on the market, so market power. In tutorials, I will talk about homogeneous goods, like goods not being the same. We are going to go over externalities, over public goods, over information asymmetry towards the end of the term. And we're going to see how each of these violations will impact the market equilibrium outcome. That's it for this first introduction to this first review of competitive markets. In the next lecture, I will talk about monopolies. So I will break the first condition of perfect competition, the case where there's one unique supplier of the good on the market. Have a good rest of your week and see you in the next one. Bye.